We're going to talk about the elimination method. This is another different kind of method that you can use to solve a system. The idea here is that you're trying to cancel out either a y variable or an x variable by lining these up vertically and combining them. So here's this one. And I don't have to do any manipulating because if you look here, I naturally, if I'm going to go ahead and combine these, I naturally am going to be able to cancel out that y variable. 2x plus 3x is 5x, and then positive 5x and negative 5x cancel each other out, and this is 35, and I can divide both sides by 5 and figure out that x is 7. But remember, these come in the form of an ordered pair, so I have to go ahead and use the fact that I know that x is 7 to find y in one of those original equations. So here it is. I'm going to subtract 14 from both sides. 5y equals 10, so y must be 2, and so my ordered pair is 7, comma 2. What happens if it's not beautiful, though? This one's a perfect example of things not being beautiful. I have to do something to create a scenario where these are canceling each other out. And the rule is this. I can multiply the top row or the bottom row by a number as long as I multiply each piece. And I'm looking here and I'm just noticing right off the bat that two of these variables are positive and negative, so they're opposite symbols. And in order to create a scenario where I am cancel out -8, I would have to have a positive 8. And I can have a positive 8 if I go ahead and I multiply this whole entire top row by 4. So that makes it 12x plus 8y equals 40. Boom, boom, boom. So now this has gone away. And now I have a new situation to deal with where I can add vertically. And this time, when I add vertically, those y variables cancel. If I divide both sides by 17, 17 goes into 68. I actually think this is a beautiful thing, even though it doesn't seem like it should be. 4 times. I need to find the y, so I'm just going to plug in 4 for x. 5 times 4 minus 8y equals 28. 20 minus 8y equals 28. Subtract 20 from both sides. And divide both sides by -8. And that will give me a y value of -1. The ordered pair is 4, comma, -1. Kind of cool. There is down here the breakdown of how that goes if you need to take a look at steps. But it's pretty much the same thing each time. And I am realizing that this belongs down here. There's 2 examples for you to try here. I want you to pause, then you can come back and you can look at the answers and see if you did it properly. Here's the first one. Notice that one of the elements is a fraction, and it is the right thing because I double checked it online. I'm going to do the next one. Here's the second example. I went ahead and multiplied the first one equation by +3 so that I was canceling out x's, solved for y, used that value to figure out what my x value was. This next page is looking at a couple more elimination questions that I'm going to go ahead and give you answers for in just a moment. But I want to look at this one here. This one is looking at dog food and using systems to solve this problem. So Jim Johnson is a local vet, and he has prescribed a diet of 24% protein for a client's Great Dane. Jim has 2 types of dog food shown below, but neither is 24%. The client wants 225 pounds of food to serve the Great Dane until the next appointment. And how much of each type should they have? So notice one is 21%. And one of them is 30%. So I'm going to say that this is the x. X is going to represent pounds of this one, and y is going to represent pounds of this one. And I know that if I add this many pounds to this many pounds, I should end up with this many pounds. You must agree, hopefully. I also am going to say, from the protein point of view, that if I was looking at how much protein, I would have 0.21 per pound, 21%. And then I am looking at Y, and that means I'm going to get 30% of protein per pound. And then I also know that altogether, my goal is to have 0.24% protein, and we are going to end up with this many pounds. And so this is the system that I'm going to have to solve. I'm going to go ahead and multiply this whole top row by either negative 0.21 or negative 0.3. That way I can eliminate one of my variables. Let's do negative 0.3. I'm going to distribute it to each piece. So I have negative 0.3x minus 0.3y equals 0.3 times 225, which is 67.5 minus 67.5. So now I've gotten rid of this and I've started with a fresh one. I am going to take away, it's got 0.21 minus 0.3 is minus 0.09. These cancel. If I say 0.24 times 225, that gives me 54. So this right here is worth 54. And if I take 54 and I combine it with negative 67.5, so it's 54 combined with negative 67.5, I get negative 13.5. And I have to divide both sides by negative 0.09 to get x alone. And if I put that in my calculator, divided by negative 0.09, that gives me 150 pounds of x. 150 pounds. So if I have 150 pounds of x, that must mean I have 75 pounds of y, because altogether I'm going to have 225 pounds. So this is how much I had for x, how much I had for y. I'm going to pause and I'm just going to do the examples above so you can compare your answers if you would like a little bit more practice. But that is the end of these notes otherwise. So I'm just going to pause, show you the answers to the top, and then you are done with this section of notes. Okay, let's look at these examples up top. A was a little challenging because everything was a fraction, but, you know, got through it. B is interesting because once you try to set up a situation where you are canceling out x's or y's, you end up canceling out everything. So you end up with 0 plus 0 equals 0, and you have to ask yourself if this is a true statement. If this is a true statement, then we would say this has infinitely many solutions, because no matter what we plug in for x and y, it's going to end up just being true. If this was a false statement, for instance, if this was 0 equals 2, then this is a situation where there is no solution, and that could be a thing that happens. So make sure you're looking out for those weird situations.